you talked about. I mentioned I've already got 4 talks dealing with the whole insects and Brix thing. And so he asked for a second one. This is the one that he asked me to do. And so if you do not like this presentation, it's Ty's fault, because he could have chosen a better one but didn't. And so he chose the inferior one. So if you like it, then I'll take the accolades. If you don't like it, everything goes to Ty. So what are we talking about here? Raising Brix, lowering Brix. This is one of the questions I get a lot, but it's not from both directions. Everyone wants to know one thing from me. How do you raise Brix? That's it. How do you raise Brix? No one ever asks me, how do you lower Brix? But in the process of coming up, this is a new presentation, 2024, in the process of coming up with this presentation, I cannot discuss raising Brix without discussing the process of lowering Brix too. Because when you make a decision to play games with the crop, sometimes it lowers it, sometimes it raises, sometimes you just need to stop doing something that's lowering it, and then it raises, and that's not because you're actively trying to raise it, that's just because you stopped doing what you should not have been doing. And so that's why you see the raising Brix, lowering Brix going on. I'm going to be talking about a little bit of both. So I am going to spend a little bit more time talking about lowering Brix and how this happens. I've got, at the end of the presentation, I'm going to talk about some of the products that we often use in order to raise Brix, but the discussion needs to start somewhere. And so let us begin with this presentation. I've already told you this before. If you were not paying attention during the first, then you missed out. And I'm not going to repeat it again. But insects are only going after crappy food. I've said it. Now I'm moving on. I've also showed you this too. This is the chart. It's become somewhat famous over the past 12 years. And this chart gives you an idea of where your crop is. And I can tell you how expensive you're raising your crop based upon where you are in this Brix reading, because it gets a lot less expensive when you're out there due to the decrease in inputs. And that's where profit comes from. It doesn't come from yield. How many times have I heard this? It's yield, yield. 180 bushels went up to 185 this year. You know, like, I really don't care about your 5 bushels. All I want to know is were your inputs decreased? Because if they were, you were more profitable. And that's more money that you took home. And that's important to me because I've got an 8th child on the way, and it should be important to you. Do not be embarrassed about making money. All right. And I've also told you about the insects and the different ways. So I can tell what the Brix readings are going to be by just looking at the insects that are attacking the plant. We had a quick discussion during lunch at our table, and we were talking about these factors, and I was able to tell some things just by listening to the insects that are being brought in. As a matter of fact, you can even tell the succession of insects as a crop is going downhill, and I spent some time talking about that on the internet. So if you want to read or listen to the citrus presentation, the 100-year citrus presentation, that is on YouTube, should you find yourself so inclined to do so. All right, here we have a fact. 80% of the crops that I test are between 2 to 10. Does this mean that all of the crops are between 2 to 10? No, I didn't say that, because 20% are going to fall outside. Some will be below 2, not often. Some are going to be above 10, not often. But 80% are going to be between 2 to 10. There have been, and Ty was just mentioning this too, how we've got all of these factors, and well, we couldn't raise Brix, and the Brix is remaining the same. Many people say I can't raise the Brix at all. This is a bunch of hocus pocus. It doesn't work. I can't get my Brix up. This makes no sense. I'm putting it in the drawer. I'm not going to use this thing again. I'm done. And they tell you Brix doesn't work. No, it doesn't work for you, because maybe you don't know enough about how it works. This is part of the reason why I'm here, is in order to teach you a few things, to show you that it does work, and it's a powerful indicator and dirt cheap, too, because I'm trying to save you money, always trying to save you money. So, 80% of the crops grown between 2 to 10. Why am I so sure that I'm right? Why? Because I know what's coming up next time I push this button. Most of the plants on planet Earth are not crops. Most of the plants on planet Earth, 95% of the plants on planet Earth are not crops. And I know that if I measure those, about 80% of them will be between 8 and 18. That's how I know. So some of you, and I can say this in Indiana, I might not be able to say this in other states, but this is saying that God knows what he's doing. That's what this slide is saying. And so you have to wonder how when I'm consistently doing crop plants and then doing any plant that may be along the farmer's field or just going out there and trying what I can walk outside my laboratory to a local forest that hasn't been touched and hit 15, 16 Brix on the trees. It's a nothing forest. It's rather nondescript, but it's relatively easy to do. So believe me, you can get higher Brix readings. But this does raise the question, what I just said. You know, God seems to have a handle on this whole thing. What are we doing that is causing us to be between 2 to 10 when we should be between 8 to 18? And that's partly what this presentation is designed to do. Okay? All right, most people have a vertical jump like this, between 3 to 24 inches. Athletes, volleyball players, they can definitely be towards 24 inches. For some of you who are not too athletic, I'm not pointing any fingers right now, I'm not looking at anybody in the eye. Some of you might be a little on the 3-inch side, but most people are between 3 to 24 inches for their jump. Athletes, of course, much more impressive. They can go much higher, sometimes even than 24 inches. What if I asked an athlete who was at 24-inch height with their leap and told them, and I want them to hold a bowling ball in their right hand and a bowling ball in their left hand, and then I'm going to test their jump again, and they don't hit 24 inches. Whoa, what just happened? And I get mad at them. I'm like, come on, you were doing a 24-inch jump before, you're not doing it anymore. It's like, I'm holding bowling balls, Tom. What are you doing right now? Come on, get with it right now. I was like, can I put one of them down? No, keep both of them right there. You just need to get on it. But they can't do it. They can't do it, no matter how hard they try. They can't even put their mind to it. I was like, oh, you put your mind to it, you'll be able to do anything. No, you can't. You cannot do a maximal jump if you're holding 2 bowling balls. Doesn't matter whether it's an athlete, anybody else, you can't do it. Did I not just make an analogy to farming? Many people come up to me, how do I raise Brix? And I tell them, in so many words, that they need to put the bowling balls down. And they don't want to hear this. I want to continue doing what I'm doing, I just want to know how to get to 14 Brix. And I said, how soon do you want to get this done? Well, preferably before the end of the season. And what have you been doing for the past 40 years? And then they tell me. And I said, this is not going to happen that quickly. But you do need to start by putting the bowling balls down. I don't care whether it's a 10-pound or a 16-pound bowling ball. You do need to put them down. Okay? What does it begin with? It begins with the seed. It always begins with the seed. Many people think it begins with that other 4-lettered word that starts with the letter S. No, I'm not talking about the poop one. And that'll be coming up in just a second. but it's another four-letter word that begins with the letter S, the seed. I hear almost nothing about it. Almost nothing. It should, because it begins with the seed. Why do I say the seed? Because if I'm ugly and my wife is ugly, what do you think the odds are that my 8 children are going to be ugly? It's going to be a pretty good chance of that, folks. Ugly, ugly, put them together, you're going to get more uglies. Okay? I understand genetics. I get it. You don't have to tell me about this. I get it. There is a possibility I could have a mutant child that is attractive. I understand that. But the odds are I'm going to have some ugly kids because the apple does not fall far from the tree. So when you are dealing with unhealthy seeds that have come from an unhealthy low Brix plant, how far do you think you're going to go with those seeds? You think you're going to talk to me and I'm going to give you some magic potion number 9 about how to take it up to 14 Brix? Do you think that's going to happen? No. There's some limitations. There's some things I can't do. I can't put my mind to making the Olympics and the 100-meter dash. It's not going to happen. You all know this. You look at me and you say, this ain't going to happen, Tom. I don't care if the dream is there. It's not going to happen. And so there are some limitations that you must be aware of. So when you ask for these expectations and you want them without wanting to change anything, you're going to have some issues and there are going to be some problems. So it begins with the seed. What do you mean by that? Well, seed constituents have sugars in them, a fair amount of it. It's an energy source. They also have proteins in there too and lipids as energy source and to make the plant. Did you know, many of you do, that the first 2 leaves from the seed, the cotyledonous leaves, come completely and utterly from the seed? Nothing comes from the soil for the first 2 leaves. Once the next 2 leaves come up, which are perpendicular to the first 2, now you've got a root system and now you're starting to pull nutrients from the soil, but it all begins with the seed. And so when I get phone calls, and I do, it's like I've got insects that are attacking my plants, and I ask them some questions, and I find out that as soon as they're putting them down, they're being picked off. First 2 leaves, cotyledonous leaves. Doesn't matter whether they're cutworms or something else. What do I need to do, Tom, in order to get the Brix up? It's like, you can't, because you got crappy seeds, which, by the way, came from a crappy plant. And that's why we're not going to be able to overcome this. The insect immediately understands that this is a weak plant and will take apart that plant, even if it's just, an inch or 2 high. That's what they do. The problem is with the seed. There's nothing I can do to do anything in the soil in order to get the Brix levels up. So we've got to have a lot of nutrients in there, all of them. Calcium's got to be in there, even sodium, copper, cobalt, all this stuff has to be in there to the seed. If the plant is not healthy, if it is a low Brix plant, this nutrition is not getting in the seed. And if it's not getting into the seed, you will not get healthy crops. That's why it all begins with the seed. All right. So these are going to be compromised seeds, whereas these over here are going to be relatively healthy seeds. Part of the reason why there is such a disparity between them, because a plant does not want to make a seed if it's going to die. It wants all of its seeds to sprout. This is the goal of all plants, but they don't, even if they should. This is what I call healthy seed. Healthy seed should have a 95 to 99% emergence rate. Then I know it's coming from a healthy plant, a relatively healthy plant. If it's below 90 to 95, I know something has been compromised. And as I'm looking out at your faces right now, I could see some of them drop, because you know as well as I do that the emergence rates on the seed packages that you're getting are not between 95 to 99%. Sometimes it's 92, sometimes it's 90, sometimes it's much lower than that. I've even talked to some who have said we're getting about 40% emergence rate from the seeds. I said, have you complained? You're spending money on a packet of seeds, 50-pound bag, and half of them aren't emerging? You ever talk to the seed company and say, what's up with this? No, never did. I was like, well, maybe you should. Because when you've got companies whose job it is to raise seeds, you better darn well be putting as much nutrition in those plants, because everything is going to go into the seed. That is the business of the seed company, is to make seeds that are 95 to 99% emergence. If they're less than that, we've got a problem. That's why I say it starts with the seed. So immediately you've got to have a good emergence rate if you expect to get a reasonable Brix level. Let's see, healthy seed contains all the necessary micronutrients. That is true. They'll have everything in there to begin the growth of the plant. After that point, the plant starts grabbing it from the soil. And all the enzymes too. Did you know that there are thousands of enzymes that are included in a single seed? So they've got a lot in there. There's a lot. There's a lot going on inside a seed. It's small. It's not that big. Some of them are really small. Some of them are a little bit bigger. Big difference between corn and carrots. But the seed is still designed in order to sprout. That's the way it's been designed. It begins with the seed, and it follows with the soil. Soil's second. Don't ever put soil first. And I know a lot of you have, because I go to conferences all the time, and I'm listening to other speakers like myself tell me over and over, it's all about the soil. It's all about the soil. Everything's about the soil. You got healthy soil, you're going to get a healthy plant. It's all about the soil. Really, it's all about the soil. You just bypass the seed completely. So if you think it's all about the soil, you make your soil as healthy as you can get it, and then I'll hand you some of the seeds that you guys are being fed, and I'll say, good luck. Show me a good healthy plant with your healthy soil, because you bypassed the most important thing, the first thing. First, seed. Second, soil. Let's discuss soil a little bit. Types of soil. This is what we're all familiar with, the sand, silt, clay, loam soils. There are also different degrees and variations of this, and you've heard all the time. I mean, the universities are putting out these complex maps of different soils, and it's emphasized to the point where other things are being de-emphasized. That's what I feel, because soil can usually raise a reasonable plant if you have a little bit of that. You never have 100% sand, not even in Florida. We usually don't get 100% clay, not even in Georgia. And so because of this, there are usually variations. So there's a lot more to it than that. There is, for example, these are just the different sizes of them. I think you're all familiar with that. The soil has different percolation sizes for that. But we also have rock. Rock is important. This is not, in many cases, by some, considered to be important. Not something anyone wants to really care about, but rock is important. It can be a component of soil, or it can be completely separate from soil. But rock is one of the most important things that a plant needs to grow. Why? In the first presentation, I taught you how important it was to have micronutrients. A lot of those micronutrients are metals, and they are found in rock. So when you have adequate levels of rock, you can actually raise very good, healthy plants, because the NPK has been emphasized. It needs to be de-emphasized, because it is amazing what you can do with rock. Lithophytes, plants that grow in or on rocks. They survive on a diet of sunlight, rainwater, and purely those minerals that they extract from the rocks they inhabit. If you understand that some plants can be raised just on a rock, this has got to change your viewpoint of how all plants on planet Earth are working. This is an understanding of how important rock is. This tree doesn't have any root. They're all exposed. We're all told this is bad. Any tree with exposed roots, it's bad. It needs to be in soil. Well, this one is just wrapped around a rock and is doing quite well. I will admit to you freely, they do grow a little bit slower if they don't have the soil. But many of them do just fine eating the minerals from rocks, which some of the acids will come out through the root exudates, and they can actually break it down in small amounts. And the Brix readings on these are definitely going to be on the order of 18 Brix. These are tough plants, incredible feeling plants. No insects will be attacking them. No fungus would dare attack them. They're tough, and they do very well. We have trees that just go right out of the side of a cliff. This is not something that we were anticipated to seeing, but I'm trying to emphasize to you how important rock is, because I'm trying to educate you on things that you may not have thought of before. And here are some other examples. Trees just growing straight out of a rock. They have almost virtually no attachment to the soil. Sometimes they have a small attachment, and at that point they can usually grow a little bit faster when they do so. But these trees are doing just fine just in rock. The same thing goes with your crops. If you have rock, we've got paramagnetic rock out there, we've got soft rock phosphate, we have rock alternatives out there which add, in part, in a substantial amount of health and will increase the Brix of the plants. So I think I've said enough about rocks. Let's move on to the soil and the microorganisms in it. The microorganisms are important too. I mentioned in the first presentation. Why are they important? Because they are taking micronutrients, minerals, detaching them sometimes from rocks, and allowing the plant to pull them up. And at that point, you get higher Brix levels when you have the bacteria and the fungi doing the work for you. We've all heard about the bacteria and the fungi. The larger ones also have their place, the nematodes, microarthropods, and earthworms as well. But the bacteria, first and foremost, most important, and then the fungi, which usually follow. The fungi are not there unless you have the bacteria. Bacteria need to be there first. There's a certain order of events. If you have enough bacteria there, the fungi, including the mycorrhizal fungi, then start to grow and can impart health to the plant that it associates with. The soil nutrients that are found in soil, I mean, there's a whole bunch of them. It's not just N, P, and K. We've got a lot of other things in the soil that need to get into the plant, and one of the most important ones is the last one here, calcium, to the point where calcium has even been considered to be possibly a macronutrient where we need to take it as seriously as NPK. I would argue more seriously than NPK. What contributes to lowering leaf Brix? Insecticides, fungicides, and herbicides. If I want to lower the Brix readings, I can usually put these up, put them out, especially if I've got all three, and I can lower the plant Brix. I can measure this. Life in the soil. Why is this a problem? Because herbicides kill what? Well, their goal is to kill the weeds. I get that, you get that. That's why we put it out. Side effect, it kills microbes too, and a lot of them, very well. Fungicides kill fungi. Side effect, they do kill microbes as well, especially the mycorrhizal fungi. Mycorrhizal fungi cannot grow. When the fungicides are put out, we lose the benefit of those. Insecticides kill insects. Duh. Side effect, they kill microbes too. So if you are spraying all three of these on your soil, you're doing a good job of cleaning out your soil from microbes, which is going to lower the Brix, which is going to make your plants more easily attacked and will cost you more money. You will have to put an insecticide out, oftentimes a fungicide. Ty was already mentioning two. It's about 10 Brix. 10 Brix, you don't have any fungus problems anymore. Insects, it's a little more along the 12 to 14 range. Fungus just doesn't take hold at 10 Brix. You're usually in good shape at 9. But these are the levels that get done where you can actually save money. If you don't need to put something out, don't put it out, because that's costing your family money. So it gets much worse than this. You know, being an entomologist, I've got to deal with the chlorinated hydrocarbons, the organophosphates, sometimes called OPs, the carbamates, the pyrethroids, and the neonics, or the neonicotinoids. And what are you told? You are told that the most important problem that you need to do with these insecticides is to stave off resistance, because the insects are getting resistant to our chemicals, and they're very good and very quick at doing that. So, in order to stave it off, you should use an OP, and then put down a pyrethroid, and then put down a neonic, and then cycle through this in order to stave off resistance. And in so doing, you are selectively killing certain microbes with the pyrethroids, certain microbes with the OPs, and certain with the neonics. You're also doing a good job of cleaning out the microbes, which compromises the health of the plant. And so we have more problems that are associated with that. Therefore, either cutting it out, of course, but also reducing the amount. When you reduce the amount, you kill less microbes. And there are ways to reduce it. Not necessarily down to zero sometimes, but even a lot lower than was talked about this morning. High salt fertilizers, very effective at lowering Brix levels. You can usually measure that within 24 hours after it's applied. When you have the power in your hands, it's amazing what you could do with that power. High salt fertilizers, why is this a problem? Well, it's necessary. Why? We put them in a salt situation so that they don't explode. Fertilizer has the tendency to explode. Fertilizer plants occasionally, not often, sometimes explode. We're trying to stabilize them. We stabilize them with salt. So these NPK fertilizers are high salt. Many of them are high salt. Not all of them are high salt, but a good number of them are. And when you're putting down these high salt fertilizers, I measure it and the Brix goes down. What does that mean? Which means the plant doesn't like it. That's what it means, even if it greens it up. And from the Bible, and I suppose I can mention this in Indiana, when you destroyed your enemy, you would then sow salt in it after you killed them. Why? To prevent them from growing crops so that they don't recover in a few generations and then come back and kill you. Okay? So they knew, and this is a quote from 3,000 years ago. We have known for 3,000 years that if you want to kill plants, you put salt on it. And here we are in 2024 still putting salt on it. We're not realizing, and we should, that this is not really the best thing for the plants. Sadly, it becomes a little bit more necessary when you're dealing with a low Brix plant because they have difficulty feeding themselves to a greater or lesser degree, as I mentioned in the first presentation. The high salt index fertilizers are a big problem. Over-application of fertilizers, which sometimes happens. Sometimes it can be a little bit lighter, sometimes it's very heavy. Fresh manure also has a lot of salt if it's not composted. If the manure is composted, the salt levels drastically decrease. If you're putting on fresh manure, there is a massive amount. It doesn't matter what the manure is. It doesn't matter whether it's human manure or it's manure from your livestock. If it is not composted, it's high salt. And when you put down this high salt, you will create problems, especially for some farmers who have overdone the manure. And there are ways of overdoing it. Some of you may have already reached that point, others maybe not. And there are also salt-based poisons, the pesticides. The same reason that I told you about for the NPK fertilizers being salt-based so they don't explode in your face is the same reason why most of the pesticides, not all, why most of the pesticides are also associated with salt, the sodium. They put the sodium there in order to stabilize it so that you can mix it and put it together without it killing you, because you dying is a bad thing. It's not something I want, It's not something you want. So because of this, we've also got a salt problem from that. All of this salt going down is creating problems for our crops. Again, we've known this for 3,000 years. Irrigated water in some areas is also a problem because a lot of these salts eventually pass through, make it to the water table, and then we pull up the water, measure it with an electrical conductivity meter, and whoa, that stuff is hot. And then you go ahead and spread it on your field. More salts being put on the field right now. This problem with the salts is creating a lot of problems with the Brix, and therefore making it more expensive for you to raise crops. GMO plants, notoriously low Brix. Oh, I wish this weren't true. Who wants to have a target on your back? No one wants that. But when I'm testing GMO plants, they are always low Brix. Some lower than others. Some are not too bad, depending upon how many genes have been inserted. The more genes you get inserted, the worse they get. And some of them are incredibly low Brix, as I'm about to show you. So if I'm looking at this chart right here, it's very similar to what you see is that the GMO plants are going to be 10 and below. What this does not show you, though, is that most of them are well below 10. As a matter of fact, it's hard to hit 10 with a GMO plant. And I was chatting with someone once, and he says, yeah, a farmer of mine had some GMO plants. I got it up to 12. I was impressed. I said, whoa, that is impressive. And I said, so, you found a way to overcome it. And I said, so you're going to do this again? What's the scoop? Give me some ideas. He goes, nope, not going to do it again. I've decided to not do it again. The farmer decided not to do it again. I said, why is that exactly? He said it was too expensive. We just wanted to see if we could do it. So they went at it hard. He didn't tell me all the details, but he was able to get them up to 12 Brix, and he says it's not cost effective for us to play this game. And so we don't. So generally it's 10 and below. Sometimes it's much below 10, as the case may be. So when you get sick, what do? How do you feel? You feel tired. You feel lethargic. And if you're sick, what do you want to do? Well, because you're tired and you feel lethargic, you want to go to bed. That's what you do when you're sick. So you do. You go into bed and you try to wait it out so that you can feel better and get back to doing what you love to do. This is all mediated, getting better, that is, by certain proteins, especially the lymphocytes, the antibodies, the white blood cells. Because when you get sick, the body ramps up production of the lymphocytes. Not just a little, but a lot. And when you are producing that many lymphocytes, because the body is fighting the sickness, it takes a lot of energy to make a protein. And you get tired. Can't run that marathon anymore because you're exhausted because your body is making all of these proteins in order to fight the disease. So you've got the protein production, which is based upon translation. Don't need to know what that is. Transcription, another process that requires energy. It makes mRNA, tRNA, rRNA. It also makes ATP. It is an exhausting process. The body does not want to create this many antibodies. If all of you are relatively healthy right now, relatively speaking, your antibodies are relatively low. Why isn't your body producing them a lot to prevent you from getting sick? Because it's exhausting. Your body can't make antibodies 24 hours a day, 10, 20, 30, 40 years in a row, nonstop. It can't do it. It only ramps them up when you get sick and you get tired. That's the process. We also have drugs, pollutants, and pesticides, which have to be broken down. This is all broken down by the detoxification enzymes. They include three major groups: the esterases, the cytochrome P450s, and the glutathione transferases. Why am I mentioning all these big names? Because these three big groups are big. There's a lot of them that are associated. We've got, I think, at least maybe 100 P450s just within our own body, which detoxify. These are enzymes. They are proteins. So when you are getting the drugs, pollutants, and pesticides in your system, the body has to continue to make the esterases, the P450s, and the glutathione transferases in order to fight them. You get tired. And if you get tired, your plant can get tired too. And thus, as I've just shown by analogy, we can kind of technically have sick plants that are tired. How does that relate to GMO? Well, we have cryoproteins. We found out that the cryoproteins are very good, and they were selectively done to kill, specifically Austrinia nubilalis, the European corn borer. So the original cryoproteins were done in order to kill the European corn borer, and it worked. European corn borer was not able to take a hold of the corn plants. They would lay their eggs. Plants were still unhealthy, by the way. They would lay their eggs. Eggs would hatch. Caterpillars would come out, eat the plant, die. Huge success. Great. Looks fantastic. There were problems, though, because the plant was now even more weakened than it was before. Corn earworm comes in. Then we had to come up with cryoproteins for the corn earworm, another lepidopteran pest. That's another gene. That's why we have so many cry genes that are out there. You've seen the list. When you buy this stuff, you know how many genes that are put in it. And then, as we're taking out the European corn borer and the corn earworm, the plant becomes weakened even more. This opened up, in no small measure at all, Diabrotica. Diabrotica are the rootworms, beetles, chewing on the roots. They were not being affected by the cryoproteins that were going after the lepidopteran pests. And so we came out with more cryoproteins in order to kill Diabrotica. We've now got cryoproteins in corn plants to kill the European corn borer, corn earworm, and the various Diabrotica species. We are weakening the plant to such an extent, and I measure it with the Brix readings and saying, wow, this really sucks. And the plants are attacked, often by other insects that they haven't found a cryoprotein for. But as soon as another group comes in, and they do their best in order to make another one and weaken the plant even further. This is part of the reason why the GMO process does not seem to be working. A lot of these people were involved in that. Some of them are my friends. I have some good friends, I have some casual friends, and I have various acquaintances who I know are in the industry. Great industry. It's amazing what they can do, the science. If you're a scientist, it's cool. Very cool stuff. But it's not working. And I can tell this as I'm measuring it with the refractometer and I see the results of these crops. Oh, let's see. These toxins, blah, 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 blah. Don't need to talk about that. I think I've said enough. Soybean aphid. Let's move on to that. Soybean aphid attacks soybean. Okay, this is not rocket science either. So the soybean aphid is either the number 1 or the number 2 or the number 3 pest in most of the states in the middle of the country, Indiana included. I have to take a look to see whether you're first, second, or third. Sometimes it depends upon the year. Soybean aphid is usually in the top 3. If I had to go back in time, take a look to see, let's see, let me see what I could find. Oh, the soybean has been around since the 11th century. It's been around for hundreds of years. The soybean was introduced to North America in 1765. That's interesting. So it's been here for over 200 years in this country. And Matsumura even described the soybean aphid in detail in 1917. The insect is not new. The insect has been around for a while. The soybean plant has been around for a while. And yet, if I went back in time to the 80s in my DeLorean, getting up to 88 miles per hour, and talked to you about the soybean aphid, attacking your soybean, you would look at me and go, what are you talking about? I have no idea what you're talking about. I say the soybean aphid. Aphis glycinus, do you know what I'm talking about? You're like, no, I have no idea what you're talking about. Because GMO soybean was introduced in the US in 1996, and the soybean aphid became a problem in 1999. Sure, it's just a chronological similarity, but I'm sure it's not related to it. The soybean aphid was not a problem until 1996. It then developed and became so. Why? Because the soybean, the GMO soybean right now, is between 3 to 5 Brix. Almost all of the GMO soybean is between 3 to 5 Brix. I was talking to Ty about this, and he said you planted once GMO soybean right next to the non-GMO. He says, that's it, I'm never going back again. Sometimes you can see it side by side. I'm telling you, it's 3 to 5 Brix. That's why the soybean aphid is going after it. Get the Brix readings up, soybean aphid disappears. Does this mean all the GMO soybean is attacked by soybean aphid? No. If you get it above 6 or 7, you're in good shape. Does this mean all of the non-GMO soybean is not attacked? No. If that also is unhealthy, it gets down to 3 Brix, that can also be attacked by the soybean aphid. But you've seen the numbers in the first presentation. It's between 6 to 8, and the aphid loses interest. The reason why the soybean aphid is such a problem is because of GMO soybean. And it's because it's 3 to 5 Brix right now, considerably lower than the rest of the soybean that is out there. This is why it's a problem. We have bred this into the problem that it is. And now I get to tell you a little bit about bioelectromagnetics. This is just like the deep dive into some deep science, because some of you are thinking right now, oh, you're scratching the surface, Tom. Can you give me some meat? And I'm like, all right. I do chemoreceptor analysis, where I can analyze an insect and tell you what it likes to taste and what it likes to smell. And this is one of my analyses that I've made. It takes me a few months to get to this point. Here's a graph right now showing the gustatory receptors in the far infrared range for the soybean aphid. As you can see, all of these peaks are relevant. Each one has a story to tell. Each one has a message. Obviously, the eye is often drawn towards the largest peak. And the largest peak is 10,476 nanometers. Let's take a look at the ammonia infrared spectrum. The ammonia infrared spectrum has 3 main regions that absorb energy. The first one, relatively small, but it's got a nice needle-like peak. Second one, a little bit bigger, nice needle-like peak. And the third one, much more grand, and it has not 1, but 2 needle-like peaks. What is that region in between the 2 peaks? Right smack dab in the middle of those 2 peaks. It corresponds to 10,471 nanometers. Do you see the connection that is now drawing itself on your screen? What this is saying, it appears that the soybean aphid has a propensity. Number 1 attractant is ammonia. Likes ammonia. That's what it seems based upon the chemoreceptor analysis. Is that conclusive? No, it's not. But it sure is suggestive at this time. Why is it going after ammonia? Because it needs a nitrogen source. In order to make a lot of babies, it needs that nitrogen source. So we take a look at the plant sap analysis. The plant sap analysis shows us that the ideal range for ammonium inside the phloem and xylem tissue should be between 10 to 30 parts per million. The average for 741 plants, soybean, is 471. I should also tell you, these 741 points, not a single point of the 741 was below 30. Some of them were in the 30-40 range. Others, I was getting 1,000, 2,000 parts per million. So now we have evidence that there is way too much ammonia inside the soybeans, and this is predominantly GMO soybeans, and that the soybean aphid is very attracted to this. and that's what it likes, and that's what it goes after. We have evidence from the chemoreceptive analysis, and we've also got evidence, as I mentioned before. So this is just for you geeks out there who really like complex graphs and like to see spectrums. You're welcome. Greenhouse plants, also notoriously low Brix. Why? You deserve a reason, shouldn't you? It'd be good to know, what are the reasons for this? Well, here I am in a greenhouse, the cut flower industry, very big industry, especially in California. I'm talking next to another agricultural consultant. To the right is the owner of the greenhouse with the cut flowers. And they're all UV deficient. So what? Does anybody in here care about a UV deficiency? Some of you might say, no, I don't care. I get it, it's not in sunlight, I guess. I don't know. Who cares about UV? Who cares about infrared? Is any of this even important to a plant? You better believe it is. UV deficiency manifests itself in very distinct ways. So if you have a plant inside a greenhouse, if you have a way of opening up the greenhouse and allowing sun to get in, you can actually stop that UV deficiency very, very quickly. So if you can open it up and allow the sun in, sometimes they slide apart. For those that don't, you're kind of screwed. First chance plants have to get out, they will take it. So if we have a broken one, they will get out, and immediately the plant will health up because it's got UV coming into at least part of the branch. And so the plants want UV. There's not a lot of it out there, but they need some of it in order to survive well and be high Brix. Why? Here are the 20 amino acids that make all proteins. I don't want to deal with all 20 of them right now. Instead, I just want to deal with some of them. Phenylalanine, tryptophan, tyrosine, and cysteine. Those are the only four that I want to talk about right now. Why these four? Why did I leave out 16 of them? Because they are the main amino acids that absorb ultraviolet energy. And they are found in all proteins. You will find cysteine, because that forms the cysteine bridges. Phenylalanine, tyrosine, and tryptophan. You usually see less amounts of tyrosine and tryptophan, sometimes 1%, but it's still there. They have a job to do. Part of it is to absorb UV. I'm not going to tell you the reasons why. I don't want to go into the details why. But understand that UV absorption is also important. And we've even got to the point where we can characterize the UV absorption, and we know exactly what it is. We've got levels of 5,600 for tryptophan. So all these numbers are out there. The other 16, very nominal attraction. Glyphosate kills plants by interfering with the synthesis of the essential amino acids, tryptophan, tyrosine, and phenylalanine. I'll wait. Glyphosate kills plants by taking these three out, essentially making it UV deficient and killing it, even if it's outside. Look at the similarity between it. The cysteine is not there because the cysteine is only effective when it forms a bridge. Cysteine does not absorb by itself. As a bridge it does, and it comes in at a modest 125, but it's doing the same thing. We see the same symptoms when we are spraying glyphosate and on the plants and in the greenhouse. It is the same insects. The aphids, the white flies, the same insects that we see under these similar situations, because they're doing almost exactly the same thing. So there's chemistry involved. If I'm going way above your heads right now, I apologize, but I know some of you are absorbing this right now, and I need you to understand why things are the way that they are. Irrigation issues are also a problem too. We have found out that drip irrigation is a serious problem, because drip irrigation, it's usually found in drier climates, is forming root balls. So it drips down, the roots all come around it, they form a little ball. This is not considered to be healthy for a plant. The plant has a lower Brix because of that. So The wheel line sprinklers, much better. Those work out pretty well. The center pivots, of course, are okay as long as it's within the circle. And if we have something on the ground that's usually spitting up, that's usually good enough too. But drip irrigation is a problem. The other ones we're not finding as many issues with, so that's some good news. The water quality, which is related to the irrigation issues, the water quality is an issue. Ty is going to mention the green lightning situation. And so if you have water quality issues, you're going to have problems. A lot of industries have come about. We've got Rainmaker, which is known for putting a lot of oxygenated water down, has its benefits. We've got green lightning. Ty will talk about that in just a second. Green lightning is putting out a significant amount of nitrogen through nitrates into the soil, and this water is treated in a particular way to make it more amenable to plants. And so this just gives you an idea. This is a southern magnolia tree. Unless you've been down to the south, you may not have seen them, but green lightning was applied to this tree, which I knew, because I've been looking at it for over 10 years, had a nitrogen deficiency. So I placed some of the green lightning around it, and the new leaves that came out were approximately 4 times larger than the small leaves that I've had for the past 10 years. All of the leaves, the new leaves that came out, all of the new growth was big and just as green. It still looks as green, but we had a massive increase in size, meaning they're bigger solar panels. And they have bigger solar panels. That means they're absorbing more energy. That means they're going to be photosynthesizing better. That means they're going to be higher Brix. Compaction. Why is compaction a problem? Because there's no oxygen in the soil. And when you need the aerobic microbes to get those nutrients up into the plant. And if you don't have the aerobic microbes there, the plant is usually at a lower Brix level. Compaction does not work well for plants. They like a little bit of ability to breathe. The roots do. So sometimes it's called high mag soil. You may have heard of high mag soil before. That's another way of saying that you have compacted soil. Oxygen, highly paramagnetic substance, and highly reactive is just not there. It's not doing the job that it should. And oxygen is a very important part to plant life. So we need that oxygen. If we don't have it, the plants will be lower Brix. We also need to make sure we have about an 80-20 relationship. We should have about 80% aerobic bacteria and about 20% anaerobic bacteria. We shouldn't be 100 and 0. You do need anaerobic bacteria. They have their place. I'm not going to go into the reasons why, but you should never have it reversed. You should not have 80% anaerobic bacteria. And if you get it tested, and some of you do, if your anaerobics are too high, that's a major problem, and that's part of the reason why you may be suffering. The high density planting I alluded to in the first presentation. Plants do not do well when they are put too close to one another. Everyone gets a little uncomfortable when this happens. So if I come up and I get really close to someone, eventually he's going to start to get uncomfortable because I'm getting a little bit too close to him. You see how we feel, the human beings? And the plants are doing the same thing. And the reason why is because they don't like to be that close to one another. Can they be very close? Sure. We all like to be close to our family, but we have our limits. High density planting can be a problem. I talked about this in citrus, is because we have ground underneath, a lot of roots, and they might extend about that far down and about that far out. They go to about the same width as the canopy, roughly speaking. And so that's about where the roots will be found. Now, we have a high water table in Florida, which is a problem. So because of that, the water comes up a little too high. Roots don't like it. They don't like to be down in water, submerged in water. And so the roots extend out. And because of that, we've now got a short and extended roots out. And when this happens, and you plant the citrus trees too close to one another, the roots overlap. And then the Brix goes down because they're now competing for the same space. And unless you're putting enough nutrients down, they are going to suffer. And once they suffer, it becomes more expensive for you to take care of the citrus industry, which, if you haven't heard, is slowly going downhill. High density planting, we got this one first. Yeah, this is citrus. You're like, oh, these are shrubs, Tom. No, no, no. That's citrus. That's how dense they are now. These trees, they're huge trees. If you've ever seen them full grown, they should not be this close to one another. This is what they're doing now. They've now gotten to the point where they essentially just look like hedges. And these are all notoriously low Brix. They're all below 7. Most of them are between 3 to 7 that I have measured. So the citrus industry is in a lot of trouble. Now, what constitutes raising leaf Brix? I've already mentioned some of the things already, but I need to mention some of these so that we understand this a little bit better. Sugar is the big one, and you better know why by this point. We've got low Brix plants not producing enough sugar. What does that mean? If we put sugar in the soil, everything changes in a hurry. Sometimes, as I mentioned to some others at lunch, 50 to 75% of your problems will be taken care of just by putting sugar down, because this is what the plants want to do. We can help the process along. Molasses is best because it does have a lot of micronutrients in it. Brown sugar, second best. White sugar will work. You can definitely do white sugar if you want, but you are putting the sugar down in order to increase the microbial content, and we always get a jump in Brix. Fish emulsion. Microbes love that stuff. Any of the fish emulsions. Which one's better than another? I don't know. They're all good. Organic Gem, Neptune's Harvest, these are some of the big ones. They're all fine. They're all good. I really don't care. I don't care what fish you use. They all have good effects. So get them into the soil if you can. It's also a pretty good nitrogen source as well, but the microbes really love them, especially in unison with the sugar. Soft rock phosphate. Great stuff. I talked about the importance of rock. If you've got a soft rock phosphate, it's usually broken down very quickly. There are usually a lot of micronutrients in the soft rock phosphate. It's just not about the phosphate. There are other things in it. Massive effects. Usually this is a little bit longer. You can't put down soft rock phosphate and expect a result within 24 hours. You can get a result in 24 hours with sugar, but you can't get it with soft rock phosphate. Therefore, you really got to put this down now, or at least before your crops go down, and give them a chance to pull and break apart that soft rock phosphate. The kelp, the seaweed, all of it's good. Which one's better than another? Don't know, don't really care. Any type of this stuff is almost always beneficial. We've seen sometimes modest jumps in Brix levels when we put down some of the stuff. Judicious tilling, obviously you can go crazy. You can create a lot of problems for yourself. But if you are not tilling, you are not getting oxygen in, and you will have too much compaction. And I am dealing with low Brix plants. So I have many proud people, maybe some of them in the audience, who will tell you I don't till. And I'll say, how long have you been not tilling? I said, if you've been going more than 5 years, and I went on your property, I'm going to get some low Brix readings. As a matter of fact, I don't even have to go on your property. I'm telling you right now, if you have not tilled in 5 years, you're going to have low Brix plants. They're not going to be as high as you want. So you're going to need occasional oxygen to be put into the crop. Many of you are aware that this will actually increase the oxygen level, and many people, certainly that have reported on the internet, and I have spoken to hundreds of them who say, wow, I really get a jump after I just do one till. You don't have to go crazy. You don't have to go out there and till 15 times in a season. But occasionally, we do need to turn things over because metals sink, and we want to stop them from getting too low. So nutritional supplements. I am as general as possible with the nutritional supplements. Most of the companies out there, and there are a few thousand products out there, that are putting down nutritionals are either going to do nothing or raise your Brix. We have not noticed major drops based upon many of these products. So because of that, most of the nutritional supplements, and there are a lot out there, some of them I've just mentioned up here. These are also types of nutritional supplements where we're not dealing with the chemical farming aspect or the salt-based trying to kill the plants and lower their Brix. I'm trying to give you an opportunity to health up the crop so that you can stop using some of the inputs and make money. That is what I'm shooting for you to do. Alrighty. Let's see, what was I doing with this slide? Oh, this is just to remind you again, as I'm kind of closing out the presentation, about the insect groups, but you've seen it. I've already given the first presentation, and you've seen this before too. No reason to repeat it. I just put it up there for emphasis, and I'm done. So you have now seen 2 of the presentations. If you did not like this presentation, I told you this is Ty's fault. It was his choice. There are other presentations to give. Maybe you'd like them more, maybe you'd like them less. I really don't know, but this is where we are at. I have now completed the 2 presentations that Ty wanted me to give. I hope you've enjoyed yourself. I hope you've got some new ideas to work with. I do want you to be successful. I like hearing about successful stories. Do I have time for a question?
Sure.
Okay.
I'm worried about the kids. You have a beautiful wife.
She's beautiful to me. She is, oh, absolutely. Of course I think she's beautiful, but I will tell you, when she's pregnant, like she is now, occasionally there are some moments where the beauty flees temporarily. It can come back, but I can find myself, in the doghouse or sleeping on the sofa if I'm not careful about it. So she is, see, we're doing March, so she's pretty far out, and she's just looking in the mirror every day. I'm fat. I was like, no, you're pregnant.